Hello Mandela class, welcome to your third maths lesson of this week. Your learning objective today is can I use my understanding of repeated addition to represent a two-digit number multiplied by a one-digit number with an exchange. So this is a bit different to our previous lesson because our previous lesson was just focused on multiplying a two-digit number by a one-digit number, but there was no exchange. So today we're going to see how it works when we need an exchange. To start the lesson off, you don't have to write these on a piece of paper. You can just look at them and match them visually, or if you want to write them down on your scrap paper, that's fine too. So match the addition calculation with the appropriate multiplication calculation. Here we have got 13 plus 13 plus 13. Which one of these multiplication number sentences does that match with? Well, it matches to 13 times 3 because 13 is being added together 3 times. So 13 times 3, or 3 lots of 13. 21 plus 21 plus 21 plus 21. Which one of these multiplication number sentences does that match with? We've got the number 21 added together how many times? 1, 2, 3, 4. So how many groups of 21 do we have? 4. So it matches with this one. 4 times 21. 4 groups of 21. How about 19 plus 19? How many equal groups do we have and how many are there in each group? We've got 2 groups and there are 19 in each group. So 2 times 19 matches to this one. And finally, 33 plus 33 plus 33. Well, we have got 3 groups of 33. So this one matches to that one. Okay. I want you to pause the video at this stage to calculate, try to see how you could calculate 24 times 3 using pictorial representation. Remember in the previous lesson, we did something very similar. We used pictorial representation and our knowledge of repeated addition. So here we have got the number 24 repeated 3 times. So we've got 3 lots of 24, which is represented pictorially here. You can represent that on your scrap piece of paper or on your whiteboard. I don't need to see it on Tapestry, it's just practice. And then have a go at calculating the total answer and see what you notice. Play the video once you're ready. Okay. So if you remember, we start by adding the ones together. Give me a sparkle as soon as you notice something. I'm going to start. I can see that they're organized in 4s, so you can either count in 4s or count in 2s. We'll count in 2s together. 2, 4, 6, 8, 10, 12. Did you notice anything? Well done if you noticed that there are 12 ones in the ones column and that something's not right. Why is something not right? Why is it strange to have 12 ones in the ones column? Well, we can't have a 2-digit number in the ones column. So we can't have 12 ones in the ones column. Who remembers how many we can have in the ones column? What is the maximum number of ones we can have? Or the maximum number of items we can have in each column? Well, we can only have 9, because if we have 10, then that becomes a 2-digit number. And where would it belong? if I have 10 ones? It would belong in the tens column because 10 ones do not belong in the ones column. So what do we need to do? So I have 12 ones in the ones column, and I know I can't have 12 ones in the ones column. So what do I need to do to be able to exchange it into the tens column? Can I exchange 1 into the tens column? No, because 1 does not belong in the tens column. How about 2? Can I put 2 of these ones in the ones column? No, I still can't do that. What is the minimum number that I can put in the tens column? The name should give you a clue. 10 belongs in the tens column. So what I would need to do is cross out 10 ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I would then need to exchange this into the tens column. Okay, so what I have done is I've exchanged 10 ones into the tens column. Let's have a look at what this would look like in an abstract way using the column method. So I had already counted the total number of ones. I know that 3 times 4, because I had 3 lots of 4, equaled 12, because I ended up with 12 ones. Now, I can't put 12 in the ones column because that's a 2-digit number. So I've kept the 2 from the number 12, which represents the ones. I'm sorry, I need to change my pen. Okay, I can keep the 2 from the number 12 in the ones column, and I've exchanged the tens from the number 12 into the tens column. Then I have now got 3 lots of 2, or 3 times 2, plus this extra tens that I have exchanged from the ones column. So what is 3 times 2? 2, 4, 6, plus the 1 that I've exchanged from the ones column, 7. And I'm going to write that in the tens column. So 24 times 3 equals 72. Okay, how could we use this pictorial representation to calculate 31 times 4? So we have got 31 repeated 4 times because we've got 4 groups of 31. So 31 and another 31 and another 31 and another 31. Can you represent this pictorially on your scrap piece of paper and have a go at count, or you could just use the screen to have a go at counting it and see what you notice. Play the video when you're ready. Okay, so we start with the ones. I've got 4 times 1, or 4 groups of 1. It's 1, 2 groups, 3 groups, 4 groups. So what is 4 times 1? Let's count it together. 1, 2, 3, 4. 4 times 1 equals 4. Can I have 4 in the ones column? Yes, because it is not a 2-digit number. It's not more than 9. So I can have 4 in the ones column. Then I would need to do 4 times my 3 tens, or 30, because 3 tens represents 30. Let's count together in threes because they're organized in threes. 3, 6, 9, 12. What do you notice? Pause the video. Okay. Did you notice that there are 12 tens in the tens column? Now remember, what is the maximum number we can have in each column? 9. Why can't we have 10 tens in the tens column? What does 10 tens represent? Let's count together. Put 10 fingers up and we're going to count them in tens. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So if you have 10 tens, that represents 100. Can you have 100 in the tens column? No, but you can have 90. So you can have 9 tens in the tens column, but you cannot have 10 tens because that represents 100. So what do I need to do with those 10 tens? Where do they belong? In the hundreds column. So similarly, the same way we crossed out 10 ones and exchanged it into the tens column, now we've got too many tens. Why can't I put 1 10 stick in the hundreds column? Because 1 10 stick represents 10. It does not belong in the hundreds column. Only hundreds belong in the hundreds column. And we've just realized that 10 tens represent 100. So we need to exchange 10 of them into the hundreds column. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Make sure you don't confuse 90 and 19. After 90 comes 100. And then I've crossed out 10 tens, which represent 100, and I'm going to exchange it into the hundreds column. Okay. Remember, we represent hundreds as squares and ones as circles. So don't get this confused with counters. Okay. So now let's have a look at how this would work if we were doing it in a column method. We've already done 4 times 1 to represent the 4 groups of 1. Now we want to do 4 times 3 or 4 times 30, which equal to 120 or 12 tens. So I'm going to keep 2 of these tens in the tens column. And what have I done with the 10 tens that I've exchanged? I've exchanged it into the hundreds column. So I have got 100s and 2 tens and 4 ones. So 31 times 4 equals 124. Okay, pause the video and have a look at this calculation. Can you explain the mistake? Can you spot where they have gone wrong in this calculation? I'm going to rewrite this calculation here as column multiplication. So 15 times 4, and let's do it step by step together to see where they have gone wrong. Okay, so we start off by multiplying the ones. So 4 times 5. What's 4 times 5? If you know your 5 times tables, you will know what 4 times 5 is, or you can count 4 lots of 5. So 5, 10, 15, 20. Now, the number 20 is a 2-digit number. I'm going to write it down here. Can I put the number 20 in the ones column? No, because it's a 2-digit number. I can, however, keep the ones in the ones column and move the tens into the tens column, exchange it. So I can see that I have got the number 20 here. So where have they gone wrong? Did you notice that instead of them exchanging the tens into the tens column, so by writing it underneath, they've actually written it as the answer for the tens. So how we would write it is 4 times 5 equals 20. We keep the ones there and we exchange the tens into the tens column, but we have to write it below. We haven't gotten to multiplying the tens column yet, so my tens slot needs to be empty. Then I get to multiply my tens. 4 times 110, or 4 times 10, equals 40. So I have got one lot of 4. 4 times 110 equals 4 tens, plus another 2 tens. So they've done the same here, but they've accidentally written it in the hundreds column rather than writing it in the tens column, because instead of exchanging underneath the tens column, they've exchanged into the tens column. So 4 times 1 equals 4, plus 2 equals 6. So the mistake that they made is that they didn't exchange correctly. They exchanged into the tens column rather than keeping it underneath the tens column to then add onto their tens multiplication. Okay, now what I want you to do is very carefully choose the activity that is best for you. So if you want to have a go at using Kai's method to calculate one of these, and if you feel like you find it a bit simple and you would like a bit more of a challenge, just start with activity 2. If you start activity 2 and you find it a little bit confusing, maybe move back up to activity 1 and practice those. You don't have to do all 3 activities, only if you really want to challenge yourself, okay? So choose the activity that is best for you. Well done, Mandela class, and I will see you in the next maths video. Bye.